Okay, we're going to do problem number 10 in 2.5, so section 2.5, and we're looking at problem number 10. So problem number 10 says that we have one number is 5 more than twice another number. So we're going to say that the first number is, which means equals, so we have the word is there. Is means equals 5 more, so we have 5 more, that means it's going to be 5 plus, and twice the other. So twice some other number, and we're just going to call that n, where n is my second number. If there's sum, well, first of all, what does the word sum mean? Sum means addition, so that means we're going to be adding. So if there's sum, there being the two numbers, so the sum of the two numbers is decreased by 10. So that when I say decreased by 10, that means we're going to subtract 10. The result is 22. So we're going to say that's equal to 22. So now I'm going to plug in the information that we know. The sum of the two numbers. Well, what two numbers do I have? Well, my first number is 5n plus 2n. So that's my first number. And my second number is just going to be n. So the sum of two numbers, here's my first number, and I'm going to add my second number. Then I'm going to subtract 10, and that has to be equal to 22. So this is the first number, this is the second number. I'm subtracting, decreasing by 10. It's going to equal 22. And then it says find the numbers. Well, the number, when I go to solve this problem right here, the number I'm going to find is the second number because n is representing my second number. So I'm going to go through and solve this problem. I'm going to remove the parentheses here. I don't have anything in front of the parentheses. I don't need to worry about the distributive property. So I have 5 plus 2n plus n minus 10 equals 22. Then I'm going to combine like terms. I'm going to combine my n's that are on the left side here. So I have a 2n and an n, that gives me 3n. And I have a 5 and a minus 10, so that's going to be a negative 5. And that has to be equal to 22. Then to solve the problem the rest of the way, I'm going to add 5 to both sides, trying to get this 3n by itself. These 5's cancel out, and I'm left over with 3n equals 27. And then to get the n by itself, I'm going to divide by 3. And I end up with n is equal to 9. So I have my one number is 9. To find my other number, I'm going to need to take 9 and put it back into my expression that I had up here for the other number. So I had 5 plus 2n is my other number. So I'm going to take 5 plus 2, and then instead of n, I'm going to be writing in my 9. That's going to be equal to 5 plus 2 times 9 is 18, which equals 23. So I have one number is 9, the other number is 23. So my two numbers then are 9 and 23. The next problem we're going to do is again in section 2.5, and we're going to be looking at problem number 14. And here they've conveniently given us a chart, and it says Justin is 2 years older than Ethan. In 9 years, the sum of the ages will be 30. Find the age of each boy now. Okay, to do this problem, let's look at the chart. We have Justin and we have Ethan, and we're looking at how old are they now and how old are they going to be in 9 years. So right now, Justin is 2 years older than Ethan. Well, we don't know how old either one of them is. But Ethan, they filled in a little chart for us, and they said, well, what if Ethan is X? Well, if Ethan is X and Justin is 2 years older, what would I have to do to Ethan's age to get to Justin? I'd have to add 2 years. So Justin's age now is going to be X plus 2. 2 years older than Ethan. In 9 years, the sum of the ages will be 30. So in 9 years, their sum, their ages, when we add them together. So in 9 years, maybe we should write this down. In 9 years, the sum, which means we're going to add the ages, that's what sum means, will be, which means equals 30. So in 9 years, the sum of their ages, so we're going to have to add their ages together, is going to be 30. So what I need to know is, what are their ages going to be in 9 years? Well, if Ethan is 10 right now, how old will he be in 9 years? So if Ethan is 10, how old will he be in 9 years? Well, that should be pretty straightforward. We need to add 10 plus 9, which gives me 19. Okay, well, we don't know how old Ethan is. Ethan is X. So if Ethan is X, how old will he be in 9 years? Okay, well, before we said what if Ethan is 10. Now we're saying what if Ethan is X. So instead of having a 10 here, we're going to put an X. And we're not going to know how old he's going to be. So what we're trying to do is fill in this little column here that says that if Ethan is X, in 9 years, Ethan's going to be X plus 9. Under the same thought process, if Justin is X plus 2 years now, in 9 years, he's going to be another 9 years older than what he is right now. So he's going to be X plus 2 plus 9 years old. So his total age is going to be X plus 11. Okay, so now we're going to use that information and this sentence that we came up with. And the sentence says, in 9 years, so when Justin is X plus 11 and Ethan is X plus 9, the sum, so if I take their ages and add them, should equal 30. And that's what I'm going to do. So X plus 11, that's Justin's age. And then I'm going to add X plus 9, that's Ethan's age. And that has to be equal to 30. And I'm just using the sentence that I had from up above here. I'm not doing any kind of distributing. There's no numbers out front of my parentheses, so I can just go ahead and remove my parentheses. I'm going to combine like terms on the left side. I have an X here and an X here. That makes it 2X. And 11 and 9 makes it 20. That's equal to 30. I'm going to subtract 20 from both sides, trying to isolate the term that has the x in it that I'm looking for. These guys will cancel out, and we're left over with 2x equals 10. And then I need to get x by itself, so I'm going to divide both sides by 2. And when I do that, I end up with x equals 5. And now we need to go back to our problem, and what was x representing? X represented Ethan's age. So x is 5, which means that Ethan is 5 years old. And remember that Justin was x plus 2, so he was 2 years older, so that means 5 plus 2, and that is Justin is 7 years old. Okay, the last problem we're going to do today is again from section 2.5, and it's going to be problem number 18. And this particular problem, they haven't given us a chart to fill in, so we have to fill in the chart on our own. And from the information that they're giving us, and it says John is 4 times as old as Martha. So it looks like we're going to be talking about John and Martha. So put down John. We're going to put down Martha. We're going to make up our own chart. And we're going to say, well, this is their age now. So John is 4 times as old as Martha. So that means I'm going to be multiplying 4 times Martha's age to give me John's age. So I'm going to make Martha x, and John is 4 times old as old, so I'm going to make John 4x because of the multiplication. It says 5 years ago. 5 years ago. So make that their next column. 5 years ago. So does that mean I'm going to be adding 5 years to their ages or subtracting 5 years from their ages? If it was 5 years ago, we're not talking about the future, we're talking about the past. So 5 years ago, their ages, the sum of their ages was 50. So we need to figure out how old were they 5 years ago. Well, Martha wasn't x, she was x minus 5 years old. And John wasn't 4x, he is 4x minus 5. So I just am taking their ages that they have now and I'm subtracting 5 years from them. Then I need to take the sum of their ages 5 years ago. Sum means I'm going to add them together. So I'm going to take 4x minus 5 plus x minus 5, and their ages are 50. Combine like terms. 4x and x gives me 5x. Minus 5 and a minus 5 gives me minus 10. And that has to equal 50. I'm going to add 10 to both sides. 5x, these 10s cancel out, equals 60. Now I'm going to get the x by itself. I'm going to divide both sides by 5. When I do that, I end up with x equals 12. So that means x represents Martha in my chart. Martha is 12 years old now. And then to find John's age, we need to do 4 times x, which means 4 times 12, which equals 48. So John is 48 years old.